Welcome guys. So this is the section 2.1 problem set of the decimal number system, and here we have to find that what is the weight of 7 in each of the following decimal numbers. So we are given here some decimal numbers, and here we have to find that what is the weight of the 7 in each and every number. Okay, so first of all, what we have to do, let me start A, and in A we can see that this is 1947, and by default the base here is 10. Okay, so when this is 10, we can see that while dividing it into the base elements, we can see that here we have 7, 4, 9 and 1. Okay, so the base here is basically 10, so multiplying each element here with this base here, okay, so that would be 10 and that would be 10 as well. Okay, after it, what we have to do, I have to write the powers of these 10, and these will start from this right side. So from right side I have to start from 0, 1, 2 and 3 and putting plus sign here in between them. Okay, so that is the number which I have here, and from simplifying them I can see that here I will get 7 plus 40. Okay, or let me not write it 40 first. So it would be 4 into 10 to the power 1 plus 9 into 10 to the power 2, which is the 100th, and 1 into 10 to the power 3. So that is basically, or I can write here 1 as well. So that is now the number here which I have divided into its elements. So we can very easily see that the weight of 7 in this number is basically, here I can see that the base weight of 7 is basically 1. So that is the answer of my part here. Okay, similarly in part B of my question, let me again proceed to part B of my question, and again writing this 7, 99, 10. Okay, proceeding it in the same manner. What I will get here, I will get here 9, 9, 7 and then 1. Okay, multiplying them with 10, 10, 10 and then 10. This is the standard procedure. Okay, and after it, what I have to do, I have to start it from 0, 1, 2, 3, adding them together. Okay, and then simplifying them, I will get 9 into 1 plus 9 into 10 plus 7 into 100 plus 1 into 1000. Okay, so from it I can see that the weight of 7 is basically 100. Okay, so the weight of 7 is now 100, and it is now clear from this procedure. Proceeding to the third one here, or part C, let me solve it here. So that is now 1979. 1979, writing the base element here, and after it what I have to do, that would be 9, 7, 9 and 1. Okay, multiplying it with the base. Okay, here, and then proceeding it by writing the values of the power. So 0, 1, 2, 3. So it is very easy to see that all the powers will start from 0 and will end at the n minus 1. Okay, where n will be the total number of digits in my number. So adding them together here, I will get this one. Similarly, now simplifying it, I will get 9 into 1 plus 7 multiplied by 10 plus 9 multiplied by 100 and plus 1 multiplied by 1000. Okay, here we can see that this is the 7 and I have to find the weight of the 7. So weight of 7 is 10 here. Okay. So, in each of our questions we have found that here the weight of this 7 is 1, here the weight of this 7 is 100, while here the weight of 7 is 10, and these are the answers. Okay. So, we have calculated it by using the method which I have explained in this video. So, thank you so much, and I will see you with some more questions like this one. Hello guys. So, this is question number 2 of our section 2.1 of decimal numbers, and here we have to express each of the following decimal numbers as a power of 10. Okay. So, let us see the procedure that how to represent them as a power of 10. So, initially I have this number which is 1000. So, how to represent it? So, you have to see that whatever the number is, whatever the number of zeros here are, first of all you have to write the 10. Okay. After writing 10, what you have to do, you have to write the number of zeros available in each number here as a power of this 10. Okay. So, we can see here that here we have 1000, and for representing it, first of all I have to write 10, and after it I have to count the number of zeros here. So, this is 1, 2 and 3. So, I have 3 zeros here. So, that is why I will write here 10 raised to power 3, which is equivalent to the 1000. Okay. So, whatever it is, first of all you have to write the 10, which is the base element here, because now here we have this 1000 with the base 10. So, first of all you have to write this base here. Okay. This is the base, and after it with the base you have to write the number of zeros which are available in my number. Okay. If you want to represent it as a power of 10. Now, in part B of my question, here I have, first of all, this is, I can see that this is with the base 10. So, writing this 10 here first. Okay. And what will be the power of this 10? So, let me count the number of zeros here. So, this will be 1, 2, 3, 4, 5, 6 and 7. So, I have 7 number of zeros here. So, this is 10 raised to power 7. That is the answer of part B. In part C of my question, again this is with the base of 10, and writing the answer of this question, first of all let me write the base which is 10 here, and after it let me count the number of zeros. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So, there are 9 number of zeros, and I do not have to include this one with it. So, therefore, I will write 10 raised to power 9 with this. Okay. So, that is the answer of part 2 of the section 2.1, in which we have seen that how to represent any numbers which is composed of many number of zeros as a power of the 10. Okay. So, that is it for today, and I will see you soon. Hello guys. So, in this question we have to give the value of each digit in the following decimal numbers. Okay. So, here we are given 3 numbers. So, in these numbers we have to give the value of each digit. So, in order to do it, what we have to do, so let me start from our first number, that is 263. So, as this is a decimal number, so the base here will be 10. Okay. So, what we have to do here, first of all I am going to use the same procedure which I have used in question number 1 of this section. So, let me first divide it into the numbers. So, 2, 6 and 3, and after it let me multiply it with the base. So, base is 10 here. Okay. So, this is base, and after it what we have to do, we have to start from 0, 1 and 2 and then add them. So, these are basically the numbers which are here, and what we have to do, we have to give the value of each digit in the following decimal numbers. So, value of each digit will be here, simplifying them here. So, 3 multiplied by 1 plus 6 multiplied by 10 and plus 2 multiplied by 100. Okay. So, it will be from here this will be 3. Okay, let me write it in black. So this will be 3, and here 6 multiplied by 10 is how much? This is 60, and this will be here. So let me write them. So it will be 60 and plus 200. Okay, so these are the values of different digits in my number here. So these are basically for 2 this is 200, for 6 this is 60, and for 3 this is 3 as well. Okay, because of this procedure which I have used here. Okay, so from it we have seen that these are 260 and 3. Similarly, now for part B of my question, let me use it here. So part B, 5436, okay, with the base 10. Okay, so now let me again use the same procedure here. It will be 5, 4, 3 and 6. After it, multiplying it with the base, this 10, this 10, and then after it 0, 1, 2, 3, adding them together. Okay, and what will happen here? This will be 6 into 10 power 0 is 1, so 1 here, plus 3 into 10 power 1 is 10 here, so 3 into 10 plus 10 power 2 is 100 and multiplied by 4, so 100 here, and here 10 power 3 is 1000, so 5 into 10 power 3. Okay, so now here again similar method will be used here, where this will be 6, it will be 30, it will be 400, and here it will be 5000. Okay, so here this one is here, this is here, this is here, while this one is here. Okay, so that is the answer of part B of my question. Okay, similarly now proceeding to the part C. Okay, so first let me write their values. So 2, 3, 4, 5, 4, 3, and this is the decimal number. Now let me solve it. So here it will be 2, 3, 4, 5, 4, 3. Okay, so after it let me multiply each and every element or every digit here with 10 or the base of this number. So that will be 10, 10 and 10. Okay, so after it I have to write the values of the power. So 0, 1, 2, 3, 4 and 5. Okay, then adding them together here, so this is the number. Now simplifying them, I will get 3 into 1 plus 4 into 10, okay, 5 into 100, okay, into 4 into 10 as power 3 is 1000, 3 into this is 10,000, and this is 2 into 1 lakh, which is 1 to 100,000. Okay, similarly now simplifying them, it will be 3, it will be 40, 500 plus 4,000 plus 30,000, and this is now 100,000 or 1 lakh, which is 2 lakhs. Okay, so these are basically the values which are like this is this one, while this one, okay, each and every value here. Okay, So these are different values for each and every element here. So 2 lakh is for 2, 30,000 is for 3, 4,000 is for 4, 500 for 5, 40 for 4 here, and 3 is for the third here. So that is the answer of part C of my question. So that is the end of my question, in which I have seen that how to find the value of each digit in the decimal number. Okay, so that's it for today, which is for your concept and how to represent different decimal numbers with their values as well. Okay, so thank you so much, and I will see you with some more examples, more interesting questions in our upcoming videos. Hello guys, so in this question we are asked to convert the following binary numbers to the decimal numbers. Okay, so the first question or the first part of this question is basically this one. So let me represent it with 0, 0, 1. Okay, and I have previously told you that all the numbers in any number system can be represented with this bracket and that number system as a subscript of the bracket. Okay, so this is basically 0, 0, 1, and this is the binary number. In order to represent this binary number in decimal number system, what we have to do, so let me first write all the digits which are in binary number here. So 0, 0 and 1. Okay, so these are all the numbers. After it, what we have to do, we have to take this base, okay, and we have to multiply it with every number here. Okay, so what we have to do, let me do it like this, representing it with this blue. So this 2 here, 2 and here 2 as well. Okay, so now it is placed here. After it, what we have to do, we have to multiply it with every number, and after it we have to add them together. Okay, so here we have multiplied 2 with every bit here. So after it, what we have to do, we have to write the weights of all the 2's which we have written here. So let me start it from this right side, because here this one is the least significant bit, or will also call the LSB. Okay, so let me see here that here this is the LSB, okay, while this one is the most significant bit, or MSB. Okay, so least significant bit, least significant bit, while this one is the most significant bit in the binary number system. Okay, so let me write their weights here. So let me start it from 0. At the right hand side, or at the right most, here we have the LSB. So starting from 0, so this is 0, the second 2 is the weight of this is 1, and the last one, or the MSB, as the total number of bits here are 3, so it will be 2. Okay, so now let me calculate them. So 2 0, that is 1, and 2 raised power 0 is 1 as well. Similarly, this is 0 multiplied by 2, 1 is 2, so 0 multiplied by 2, and similarly 2 to 4, 4 multiplied by 0. Okay, so writing them here, 1 1 is 1 plus 0 plus 0, because everything multiplied by 0 is 0. So now here we will get what? We will get 1. So this is 1, and this is in decimal number system. So that is basically the binary to decimal conversion of a number. So this is part A of our question. Similarly, in part B, let me start solving it. So this is 0 1 0, again representing it with this 2 in the base. So after it, 0 1 and 0. Okay, multiplying it with 2, again the same procedure. Okay, and what we have to do, we have to then add them, and this is 0 1 2 weights of all the 2's here. So now calculating them, this will be 0, okay, this will be 2 2 2 1 2 is 2, and this is again 0 because anything multiplied by 0 is 0. So this will be now 2 raised power 10, okay. Similarly 2 to the base 10, okay. So that is the decimal number of 010. Similarly in part C we have 101. This is again in binary, writing them like 101, okay, multiplying it with 2, okay. So the basic operation here is to write the exponents of all the 2's. So starting from 0 1 2 and then adding them, okay. So it will be 1 multiplied by 1 plus 0 multiplied by 2 plus 1 multiplied by 4. So it will be 1 plus 0 plus 4. So this will be what? This will be here 5. So 5 in base 10, okay. So that is the decimal equivalent of 101. So this is all about the three parts. Similarly in part E of our question, 1010, okay. So now again 1 0 1 0. Now multiplying it with 2, because this is a base in binary number system, okay, and then 0 1 2 3 and then at the end adding them, okay. Now let me calculate them. 0 multiplied by 1 plus 1 multiplied by 2 plus 0 multiplied by 4 plus 1 multiplied by 8, okay. So here it will be 8 plus 0 plus 2 plus 0, and it will be 10 in decimal number system. So 10 is basically the decimal equivalent of 1010. In part F of our question, this is 1011. 1011 in binary number system. So 1011 and multiplying it with 2, okay. Again the same procedure which we have been following, adding them and writing the exponents of this 2. So here 1 multiplied by 8 plus 0 multiplied by 4 plus 1 multiplied by 2 plus 1 multiplied by 1, okay. So this will be 1 plus 2 plus 0 plus 8. So we will get what it would be. So 8 plus 2 plus 1 is 11 in the base 10. So that is the decimal equivalent of 1011. So the last one here is this one G, which is 1110. 1110 to the base 2. So writing it again 1 1 1 and 0, okay. Now multiplying with it 2, okay, and then writing the exponents 0 1 2 3, adding them together, and here 0 multiplied by 1 plus 1 multiplied by 2 plus 1 multiplied by 4 plus 1 multiplied by 8. So here we will get 8 plus 4 plus 2 plus 0. So ultimately we will get here 14 with the base of 10. Okay, so that is the equivalent decimal number of our binary number which is mentioned in G here. Okay, so that's it for today, in which we have discussed the binary to decimal number conversion. With the other videos I will see you very soon. Thank you so much, and I will see you soon. Welcome back, guys. So this is question number 7 of our book, and today we are going to encounter some more binary numbers, which are basically the fractional binary numbers. Okay, so you may see that here all the binary numbers also consist of this dot, which is in this case is called the binary point. Okay, so you may have seen different dots or the decimal points in the decimal number system, like 25.78 or 6.23 or so on. So this point here is basically, or this full stop is the decimal point here in the decimal number system. But here, as we are in the binary number system, so this is the binary point. Okay, so today we are going to see that how to convert these type of numbers into the decimal number. So let us get started. So let me first remove it, and let me first start my number, which is 110011.11. Okay, so now how to solve it? So here we have this binary point. Okay, so let me write it here. So it will be here, this will be here. So after it, let me write all the numbers as I used to do with the conventional numbers. Okay, so this is 1 after it, and this is 1 here as well. Similarly here, this one, okay, then 0000, and then 11. So these are basically the numbers which are in my question here, and that is basically the binary number. So now again writing 2 with each of 1 here, so multiplying 2 with it, okay, 2 with it as well, 2, 2 and 2. Okay, similarly with them as well. Okay, let me first write the exponents with all these two bases. So at the left side of my binary point, I have all the numbers. So let me write the exponents which are starting from 0, 1, 2, 3, 4 and 5. Okay, so these are all the exponents, and we have to add them then. Okay, so I have added them. So after calculating it, I will get the whole number out of this binary combination. So what to do with this number? Okay, so what, as we can see that here we have a 0. So let me draw a picture like this one here. So this is the midpoint, which is 0. So here in this line I have 1, 2, 3 up to any positive number, but here at the right side I will have -1, -2, -3 and so on. Okay, so keeping in mind the same thing or the same line here, let me use the same concept here, and here I will start writing the exponents of the base from -1 and then to -2, and then I have to add them together unless and until I will get back to the end of my numbers here. Okay, so in this way I will get this combination. Okay, so let me simplify them. So simplifying them, this will be 1 into 2 raised power 0 is 1. Okay, similarly 2 multiplied by 1. Okay, 0 multiplied by 4. Okay, this is 8, and 8 multiplied by 0. Similarly this is 16, 16 multiplied by 1, and this is 32 multiplied by 1. Okay, what to do with it? this is now my binary point, and here 2 raised to power minus 1 is 1 into 1 over 2. Okay, similarly this is 1 multiplied by 1 over 2 raised to power 2, which is 4. Okay, now let me simplify it some more here. So it will be what? This will be 1 plus 2. Okay, these two will cancel out because anything multiplied by 0 will be 0. So 0 0 here, so 0 plus 0. Okay, similarly 16 and 32 here. Okay, what about these? So 1 by 2 is 0 0.5, so 1 multiplied by 0 0.5 is 0 0.5. Okay, so and similarly 1 by 4 is 0 0.25, so adding it with 1 multiplied by 0 0.25 is this one. So this will be like this one. Now adding them together, this binary point will be here. So 0.5 plus 0.25 is, how much is this? This is 0.75. okay, and what to do, this is the decimal point, and adding them here, okay, what it will happen, so 16 plus 32 is 48, 48 plus 2 is 50, and this is 51. So ultimately I will get, adding this with this one, so I will get 51.75. okay, so that is the decimal number, and that is the answer of my part A of this question. So it is about the conversion of the fractional binary numbers to the fractional decimal numbers. Okay, so here we have a point which is called the decimal point, but the same point here we had in our binary numbers, and that was basically the binary point. Okay, so that's it for part A. Similarly, in order to start the part B here, let me write this 101010.01. okay, so part B here 101010.01, okay, or 0.01, and that is, yes, the same one here, and that is the binary number here. So now using the same concept here as we have applied in our previous question, so what to do? So using 1 0 1 0 1 0, and then this binary point, and then 0 and 1. okay, after what we have to do, we have to write or multiply 2 with every bit here. okay, so bit is basically the binary digit, and as this is a binary number, so each and every digit here is basically the bit here, so that is basically the binary digit. okay, similarly 2 with it and with it as well. okay, did I multiply it here? Yes, this one. So now what we have to do, after we have to write the exponents. So here this is first, so 0 1 2 3 4 5, and here it will be -1 -2. okay, adding them together, the same procedure which we have previously followed. okay, now simplifying it, let me simplify it. So this is 0 point, and that would be what? This is 0 multiplied by anything would be 0, and similarly what it would be, so 1 multiplied by 2 power -2 is 1 by 4. okay, similarly it would be 0 plus 1 multiplied by 2 is 2. okay, so 0 again, 2 raised to power 3 is 8, multiplied by 1 is 8, 2 raised to power 4 is 16, multiplied by 0 is 0. okay, 2 raised to power 5 is 32, 32 multiplied by 1 is 32. So this would be 32 plus 8 is 40, and 2 is 42, so it would be 42. okay, 42.1 by 4 is 0.25, so it will be here 25. okay, so now this is my decimal number. Okay, so here we can very easily see that by using or by deploying all the previously established steps, we have converted our number into the binary number, which we can see here. Okay, other questions are similar as that of this one, so I suggest you guys to use other parts of this question for your own practice. But let me give you a hint here, because here we have this question in which all the terms here are 0 except our this one and this one here, while all the bits at the right side of my binary point are 1. So what is this? So this is basically 2 raised power 0, and this is 1 2 3 4 5 6. This is 2 raised power 6. Okay, so only 1 into 2 raised power 6 plus 1 into 2 raised power 0, these are the only numbers which will be here, because all the other numbers will be multiplied with 0 and will be nullified. Okay, similarly here it would be 1 by 2 plus 1 by 4 plus 1 by 8. Okay, so now let me simplify them. So 2 raised power 6 is basically 64. 64 multiplied by 1 is 64, plus this one is 2 raised power 0 is 1, so this is 1. Okay, similarly 1 by 2 plus 1 by 4 plus 1 by 8, so 1 by 2 is how much? That is 0.5 plus 0.25, and this is 0.125. Okay, so adding them together, I will get 0.5 plus 0.25 is 0.75. Okay, and that would be 0.125 with 0.75 will be how much? This would be 0.875. Okay, so now adding this 65, because 64 plus 1 is 65. So here from this question I will get what? I will get here 65.875. Okay, so that would be the decimal number of it out of this binary number, and that is one of the easiest possible way in which I have told you how to calculate the decimal number from a given binary numbers. Okay, from the same method you can use the other parts of this question for your own practice. I am not going to solve them in this video, but in other videos I will definitely give them a try. So with this exercise problem, I am leaving you with all the other parts of this question, which are D, E, F, G, H. So I hope you will practice all of those things, and if you encounter any difficulty in these questions, so let me know in the comment section, and I will see you with some more question in our upcoming video. Thank you so much, and I see you soon. Hello again. So in this question we have to find out that what is the highest decimal number that can be represented by each of the following numbers of binary digits or bits. Okay, so here we have these numbers, and we have to know that if we have 2 3 4 5 6 or any number of bits, so what is the highest number or in decimal which is represented by those number of bits. Okay, so in order to find the highest decimal number, okay, so let me use here highest decimal number from a binary, from bits, from certain number of bits, and those bits, let me call them certain number of bits, let me call those bits as n. So their value can be here 2 raised to power n minus 1. Okay, why minus 1? Because in every bit or in any binary number, all the number starts from 0 0. Okay, just like in our combination or in 2 bits number which starts from 0 1 2 3. So 0 0 0 1 1 0 and 1 1. We can see that the highest number it can represent is basically 3, but if these are 2 bits, so putting 2 raised power n, if we put 2n here, what will we get? 2 2 is 4. So basically 2n shows the quantity of the numbers which can be represented by the number of bits, while this 2n minus 1 shows the highest decimal number from the n number of bits. Okay, so that is basically the scenario, and from it we can calculate that if we have part A, so here we have 2 bits. Okay, so the highest number here would be 2 raised power 2 minus 1. So 2 to 4 and 4 minus 1 is 3. So 3 is the highest number here, while the total number of decimal numbers here will be 4. Okay, so 4 numbers will be represented, and those numbers will be 0, 1, 2 and 3, while 3 is the highest number. Okay, so that is the concept behind these type of questions. Let me solve part B of my question. So here we have 3. Okay, so 3 will be 2 raised power 3 minus 1. So this would be 8 minus 1. 7 is the highest number which can be represented, while 0 to 7 will be 8 numbers which can be represented by 3 number of bits. Similarly, in C we have 4. Okay, so 2 raised power 4 minus 1, 2 raised power 4 is 16 minus 1, so that would be the 15. 15 is the highest number which is represented by 4 bits. Similarly, D, if we have 5, okay, so 2 raised power 5 minus 1, so this is 32 minus 1, or it will be 31. Okay, so that is the highest decimal number which can be represented by this 5 bits. Okay, similarly, any of the combination or any number of bits can be used here. Let me put or take 8 here. So this is G. So from 8 I will get 2 raised power 8 minus 1. Okay, so it will be how much? So let me use the calculator here. Okay, 2 raised to power 8. So 256 total numbers can be represented by 8 bits, while the highest number here will be, okay, so this would be 256 minus 1 and it will be 255. Okay, so the highest decimal number here will be 255. Similarly, I here we have 10. Okay, so 2 raised power 10 minus 1. So let me use here again 2 raised power 10. So it will be 1024. 1024 minus 1. Okay, or 1023 is the highest decimal number which can be represented by 10 bits. Okay, so the same concept will be used in each and every part of this question, but the main formula or the main thing here is this formula here. Okay, where this 2 of n, what is this? This basically shows, let me write it with this, right? This 2 of n shows the total number of decimal numbers represented by n bits. Okay, but while by subtracting 1 from it, I will get the highest decimal number from those n number of bits. Okay, so I think that's it for today, and I will see you with some more interesting questions which will be related to the number systems in our upcoming videos. Thank you so much, and I will see you soon. Hello again. So another very interesting question in which we are asked to find the number of bits which are required to represent the following decimal numbers. Okay, so this is one of the very important question which is very hard for the newbies in the field of digital systems to find that how many bits will be required to represent a certain decimal number. Okay, so how I do it, how I approach these type of problems. So let me first discuss that methodology first. So the first number here is this 5. So how would I approach these type of problems? So if I have 1 bit, if I have 2 bits, 3 bits, 4, 5, 6 or 7 bits. Okay, so these are the bits here. Okay, and the maximum decimal number which these can represent will be the, here it will be, with 1 bit I can, the maximum number I can get is 1. With 2 bits the maximum number is 3. With 3 bits the maximum number is 7. With 4 I have 15. With 5 I have 31. With 6 I have 63, and with 7 I have 127. Okay, these are basically the bits, and these are basically the maximum numbers which can be represented by those number of bits. Okay, so suppose when I will have this 5 here, so I can very easily see that there is no 5 here, there is no match between them, but I already know that this 3 is the maximum number which can be represented with 2 bits, while this 7 is the maximum number which can be represented by 3. So this 5 will somehow lie here. Okay, so this will be the number which will be between 3 and 7, and I know that there is never any binary point in between the bits. Okay, I have to show that how many bits, so that would be the maximum limit with which this 5 can be represented. Okay, so from this formulation I can very easily see that this will be the maximum point here, because these 2 bits cannot represent this 5. So 3 will be the number with which my 5 can be, this 5 is a decimal number which can be represented with 3 bits. Okay, so that is the method which I use. So similarly here you may also ask me that how I calculated these one. So in previous video I will also share the link of that video here. So I have showed you that it was basically 2 and minus 1. So if you put n equal to 2, okay, so this is n here. So if you put n equal to 5 here, so it will be 2 raised to power 5 is 32 minus 1 is 31. Okay, so in this manner I have calculated all these things. Similarly, systematically, how would I calculate the value of the bits which can represent this 5? So in my formulation I can see that here it can be written this 5 like this one, where n are the required number of bits which are used to represent this 5 which is in decimal number. Okay, so how to find out this n here? So I can very easily show you that this can be found out by using the log 2 of 5. Okay, so if you will find it, you will calculate it, you will get some number, so you have to round that number up to the highest term. Okay, so suppose if you got 1.2, so this means this is almost equivalent to 2, so 2 bits will be used to represent that number. Similarly, if that is 3.7, so it means that is 4, because bit is a whole number, bit is basically the whole entity, so therefore you have to round that off to the higher value, or this is called the roof rounding off. Okay, so that is here. So in order to calculate the number of bits for this 5, what you have to do, you have to calculate n log of 2 of 5, but if you see the calculator, there is no log of 2, always you will get log of 10. So what do you have to do? If you want to calculate log of 2 of any number, and you don't have the log of 2, so what you have to do, you have to use the log of 10 of that number and divide it over the log 10 of 2. Okay, so here first of all let me calculate log 10 of 2. So here log 10 of 2, this is by default 10 log. Okay, so here it will be 0.3, so 0.3. okay, so it will be used here very seldom, that's why I have calculated it. And log 10 of 5 is how much? this is 0.698. 0.698. Okay, so now dividing it over 0.3, what I will get? I will get 2.3 here. Okay, but 2.3 cannot be a whole number, it cannot be the number of bits. So if I round it off to 2 here, so what I will get? I will get 2 bits, but the maximum decimal number which I can get from 2 bits is basically 3, so it is not possible. So therefore I have told you that always you have to round it off to the higher number. So 2.3, if this is 2.3, you have to round it off to 3. So 5, if this is 5, it will be represented by 3 bits. So n will be equal to 3 for this 5 decimal number. Okay, so these are basically the two methods which are used for the calculation of the number of bits. Okay, similarly for part B of my question, here I have 10 to the base 10. Okay, the same method I can very easily told you that with 2 bits get the maximum number I can get is 3, with 3 bits I can get 7, with 4 bits I can get 15. So you will see that this is the range, and in this range it will lie. So therefore 4 bits will be used for this number, but as I am going to use the formulation, mathematical formulation here, so n will be equal to log of 10 divided by log 10 of 2. So this log 10, I have known that this will be 1. Log 10 of 10 is 1. Okay, so let me prove it here as well. Okay, that is 1, because if you want to find the log of any number, what does it mean? So suppose you have a number 2 raised to power 3 equal to 8. Okay, so that is 8. But if you have a number like 2 of n equal to 16, so you want to find out the value of n, which should be the number here. So you can very easily see that this is 4, but how to find it mathematically? For it you use log 2 of 16 equal to n. Okay, so that is the methodology for which log is used. Similarly, if you want to calculate it for log of 10 100, okay, equal to n. Okay, so what does it mean? It means that if the power of 10 is n and you got 100, so what will be the value of n? So it can be very easily seen that n will be equal to 2 here, because that is the required value of n, which will give me 100 when n will be the power of 10. Okay, I can also use it here and you will see that it confirms to my answer here. So here log of 100 is how much? That would be 2. Okay, so that is the essence of this logarithm here. Similarly, what if I want to find the value of n here? So let me calculate them. So this is already found out, and that is 0.3. So log 10 of 10 is 1, because the what should be the power of 10? That I will get this 10 here, so that is 1. Okay, so if I will use log of 10, it will be 1. Let me use it here again. Okay, so 1 by 3 or 1 by 0.3 is how much? That is 3.33. Okay, so as I have already stated that this cannot be rounded off to the lower value, so therefore whenever I have something with the decimal point here, so I have to round it to the highest value. So the highest value here is 4, so I can see that 4 bits are required. This is n equal to 4. These are required to represent this 10 here. Okay, so that is for the 10 here. Similarly, what if I want to see that how many bits should be used to represent this 15? So I can very easily see that this 15 is already mentioned here, that 4 bits are used to represent the 15 here. Similarly, in order to do it, I can also use the same formulation which I have had here. So 15 with the base 10, for it the n will be log of 10 of 15 divided by log 10 of 2, that is already known, and that is 0.3. So let me calculate it. log of 15, okay, and divided by 0.3, what I will get, this is 3.92, okay, this, which is when rounded off I will get 4, okay. So 4 bits are used to represent this 15. This is also a very important question for all of you to know, that how many bits are used for any numbers to be represented. Similarly for D, you can see that it lies here, so it is already known that the value it will have will be 5 bits. Similarly you can use the same formula here, okay. So 5 bits will be used here. Now let me pick this H, okay. Now let me use this H, and H is 160 decimal. So how many number of bits should I have to represent this one? So now let me use the same formulation which I have. So with 7 bits the maximum number I can get is 127, and with 8 bits, if I have 8 bits, the maximum number I will get here would be 255. So it lies here in between them. So I have told you that if the range is here known, the lower number and the highest number within which the number can lie, so I have to pick the highest number, okay. So 8 bits can be used to represent this 160, okay. So 8 bits will be used. So now let me use my formulation here which I have made. So 160 divided by 0.3, okay. So now it will be log of 160 divided by 0.3. So how much would it be? This is 7.3, 7.34. So again, rounding it off to the higher number, I will get n equal to 8, okay. So 8 is the number of bits which can be used to represent this 160, okay. So that is all about the question, or the very important question, that how many bits are required for any decimal numbers to be represented in the binary numbers, okay, or in binary digits. So that's it for today, in which we have discussed all the things here, and I have also shared a very simplified trick here which I use in my mind to abruptly tell that how many bits can be used to represent that decimal number. So that's it for today, and I hope you have got all the idea that how to represent these numbers. Thank you so much, and I will see you